Okay, so we're gonna look at determining whether a vector lies in the span of a set. So we have a set S here determined by these three vectors, right? We'll call, just for shorthand, V1, V2, and V3. All right, and we asked to determine whether U or W is an element of the span of S. All right, again, be comfortable with the notation, right? These little brackets here, right, mean in the span. Okay? So what I'm asking here is, if I can find those scalars alpha 1, alpha 2, alpha 3, such that when I multiply them with their respective vectors, v1, v2, v3, I get the resulting vector 1, 1, 1. Right, so, well, it turns out I can set this up as an augmented matrix, right, where the columns are the vector v1, right, so we would have 1, 2, negative 1. The next column will be 3, negative 4, 2, and then 4, negative 2, 1. And then for u, 1. Right, so our augmented matrix here, right? So that vector u, right? So here, if we think of each column representing the vectors, right? And the first three representing the variables alpha 1, alpha 2, alpha 3. Okay, so here, my goal here will be to write this in reduced row echelon form. Right, so now in doing that, I arrive at this conclusion here. We have 1, 0, 1, 0, and then 0, 1, 1, 0, 0, 0, 1. Okay. So now how do I interpret this, right? So here from previous sections, we notice here that this is inconsistent. All right, so what does that mean? That means that there is no solution to this system, right? That's what it means to be inconsistent. Or in other words, I cannot find alpha 1, alpha 2, alpha 3, right? Or in other words, what we can say is that U is not an element of the span of S. Okay? All right. So now let's check W, right? W is negative 7, 16, negative 8. So I do the same thing, right? The first three columns in my augmented matrix are going to be the same. Okay, and then here I'll reduce row echelon form this matrix. And the result we get 1, 0, 1, 2, 0, 1, 1, negative 3. All right, and then 0, 0, 0. Okay, so here it looks like we have two pivots. Right, remember this is an augmented matrix. So we have two pivots and one free variable, right? Here our free variable being alpha 3. All right, so this is telling me a couple things, right? First thing is we know the system is consistent. So there is a solution, right? Here we have a free variable, so it's telling me there's infinite solutions, but I am not interested really in finding infinite solutions, right? So I know that my alpha 2 plus alpha 3 is equal to negative 3, or alpha 2 equals to negative 3 minus alpha 3. Right, I get that from that second row in that matrix here, and I also know that alpha 1 plus alpha 3 is equal to 2, or alpha 1 is equal to 2 minus alpha 3. Okay, and I want to find one particular solution. So one thing I can do is I can set alpha 3 equal to 0. So if I do that, then alpha 1 is equal to 2. Okay, so what I have shown is I found a solution to this. So we have 2 v1 minus 3 v2 is equal to w. All right, that is the interpretation of these results, right? That I have found a linear combination here of the vectors v1 and v2. So what that means is that w is an element of the span. Okay? All right, to kind of summarize here, right? So to find whether a vector is in the span, we're going to set up an augmented matrix, right? Where the columns come from my set of vectors, and then my augmented matrix would be whatever is the vector that we want to determine if it's in the span or not. Right? And we find the reduced row echelon form. If the reduced row echelon form yields a consistent system, then I know it's in the span, right? And either it's a unique solution or it's an infinite solution, in which case you can set the parameters to whatever you'd like to determine a possible linear combination. Okay? And if the system is inconsistent, right, then it is not part of the span. All right, so again, we're just tying together topics that we did earlier, and now we're framing them in a different context here in this idea of the span of a set.